Hello friends, this video on P-Block part 57 is brought to you by examfear.com. No more fear from exam. Let's talk about some of the trends in the noble gas family. We'll talk about the electronic configuration, density, melting point, boiling point, atomic and ionic radii. In fact, there is no ionic radii here. We have just atomic radii, and that is my van der Waals radii. The electronegativity, metallic character, water solubility, chemical properties. Let's start with the electronic configuration. So the electronic configuration is ns2np6 except helium, which has the electronic configuration of 1s2. All other has the electronic configuration of, you see, ns2np6, ns2np6. All these has electronic configuration of ns2np6. Okay. Now, if you see helium, there is no d orbital. Neon, there is no d orbital. This has actually empty d orbital, and with this we'll see that there is a difference in the chemical properties of helium, neon and the other elements. We'll talk about that. Let's talk about the atomic radii. See, atomic radii, if you go down the group, it increases, the general trend, and the reason is pretty simple. Because as we go down the group, the number of shells increase and thus the atomic size increase. But if you talk about a given period, for example, you take lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So lithium will have the atomic size of 152 picometer, then 112 picometer, 80 picometer, 77, then 75, then 74, then 72, and then neon, if you see, the value has increased, right, 160 picometer. Now if you see, the atomic size is decreasing from left to right, but again it has increased, and actually it has a maximum value in a given period. You must be wondering why. See, actually there are two reasons. The one reason is, in my noble gas, the outermost shell, the valence shell, is completely filled, right? The valence shell size is same. If you talk about all these, the valence shell size is same. Now in the valence shell, it has only 1 electron, it has 2 electrons, 3, like that, but this has 8 electrons in the valence shell. Since it has 8 electrons in the valence shell, the number of electrons in the same size of cell has increased. So there is an inter-electronic repulsion. Okay, so because of the inter-electronic repulsion, the size increase. That is one theory. That is inter-electronic repulsion in my valence shell, in my completely filled valence shell. That is one theory. The second is, since these noble gas are not reactive, they don't form a lot of bonds. They don't form ionic bonds. They don't form covalent bond typically. We have example of XEF4, XEF6. They form bond, but if you talk helium, for example, neon, helium, neon, they don't form any compound. Okay, so they don't have any ionic bond or covalent bond. The only bond they have is I mean, they don't have any bond. They don't form any compound, most of them. So the radius, if you talk about the radius, they don't. If you remember, I talked about radius. We have something called van der Waals radius, we have ionic radius, and we have covalent radius. And then you find the value of these for a given element in different forms, and you take an average, and you get something like called atomic radius. Correct? Now in this case, there is no ionic radius, there is no covalent radius. Why? Because they don't form any bond. They don't form any compound. And the van der Waals radius is typically bigger size. They are bigger, right? Because there is no bond, and it is a little big because these two electrons will be separated from each other. There will be a huge difference distance between these two electrons, these two atoms actually. So the van der Waals radius is little big. So if you want, you can see my videos where we explain these kind of radius and why the van der Waals radius is big. So coming back to the point. Now since for the noble gas family, I have the only one kind of radius, that is van der Waals radius, and they are bigger. So even if you take the average of these, you get a bigger value, right? So the next possible reason why the atomic radius for the noble gas families is more is because only van der Waals radius exists, right? There is no atomic or ionic radius. Okay, two possible reason why you have a high value of atomic radii for noble gas family in a given period. The next is density. Again, density is mass by volume, right? Density is mass by volume. So if you see this trend just now here, the volume increase is what? 122, 60 is almost 30%. And then again 160 to 90 is almost 20%, and 190 to 200 is almost 5%, and then this is almost 10%. So 30%, 20%, 5%, 10%. Let me put the value. So from here, this to this is 30%, then you have 20%, then you have 5%, and then you have 10% increase in the volume. If you talk about the atomic mass, 2 to 10. 2 to 10 is what? Almost 5 times. That is 400% increase. Correct? If you talk about 10 to 18, almost 80% increase. 18 to 36, almost 100% increase. And 36 to 54, almost I'll say 50% increase. So if you see, the mass is increasing by 400%, but the volume is increasing by only by 30%. Obviously, then mass by volume, this value will increase. So as you go down the group, the density increase. Okay. The next is the melting point and boiling point. So if you go down the group, the melting point and the boiling point both increase. Now the question is why? See, the melting point depends on what? The melting point, boiling point depends on the bond, right? Stronger is the bond, more is the melting point and boiling point. Complex is the structure, the more is the strong melting point and boiling point. But in case of my noble gas, we don't have covalent bond, we don't have ionic bond, right? The only bond we have is a van der Waals force. Now this van der Waals force is directly proportional to size and mass. Correct? For atom. If you go down the group, my size is increasing, also the mass is increasing. Since in this case the only bond is van der Waals bond due to van der Waals force. If you go down the group, the size and the mass of my atom increase, and thus my van der Waals force of attraction increase, and thus my melting point and boiling point increase, because more energy is required to break this bonds. Okay, so in case of noble gas, there is only van der Waals force of attraction. The next is ionization enthalpy. What is ionization enthalpy? Amount of energy required to ionize this, that means plug one electron. Now, since these are stable, they have stable electronic configuration, they don't want to lose electrons, they don't want to ionize, and thus they have very high value of ionization energy. You see, they have very high value of ionization energy. Okay, now the value of ionization energy decreased down the group. Just ignore helium just now for now, but apart from helium, if you see, start from neon, argon, krypton, xenon, radon, the value of ionization energy decreased down the group. Why? Again, this atomic size is increasing. The helium somewhere here. Yeah, the atomic size is increasing. Since the atomic size is increasing, it is little easier to pluck electron for krypton than to pluck one electron from neon. Correct? Because in neon, the central atom is holding this electron more tightly, but in krypton, because of the increase in size, the central atom is not able to hold this electron tightly. So it is easy to pluck electron from krypton than neon comparatively. So you need little less energy to pluck an electron from krypton than to pluck electron from neon. For neon, maybe you need 20-80 kilojoule per mole energy to pluck electron. For krypton, you need only 30-40 51 kilojoule per mole energy to plug electron. In case of, in fact, it is following the trend. In case of helium itself, if you see, the value is going down. I mean, it has maximum value because the size is very small. So we can actually see that. I'm really sorry for that part. For helium also, it follows the same trend. It is just, it has a very high ionization energy. It needs a very high energy to plug one electron from helium because the size is very small. The next is electron gain enthalpy. See, electron gain enthalpy, actually, if you see, the trend is you have to ignore the helium part and then you have to talk about other. Then if you see, if you go down the group, the electron gain enthalpy, actually, the value is decreasing. Why? Again, the same reason. The atomic size is more. Electron gain enthalpy is amount of energy required or emitted to add an electron. Now, since they are already stable, they don't want electron. So, even if you want to give electron to these guys, you need to provide energy. And thus, all the values you see are positive values. Okay. Going down the group, the atomic size increase. It's little easy to add electron, and thus, if you see, for radon, it is 68 kilojoule per mole energy is required to add electron, but for neon, 116 kilojoule per mole energy is required to add electron. In case of helium, it is little less amount of energy is required to add an electron. Okay. Let's talk about the electronegativity. See, electronegativity here for helium and neon is not defined actually. For argon, it is 3.24, krypton 3.0, xenon 2.6, and this is 2.2. So if we go down the group, the electronegativity decrease. Electronegativity is what? Tendency to attract electron. The more the size is, the less is the tendency to attract electron. Also, they are stable, they are inert, so they don't have much tendency to attract electron towards itself. If we talk about the metallic character, all the elements in this noble gas, they are non-metal. They are non-metal, but still, if we talk about the metallic character, if you go down the group, the metallic character decrease, or if you go down the group, non-metallic character increase. And thus, if you see, right, these are little reactive and these are little inert. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.